Porto. Good afternoon, Porto. How you guys doing? I have to tell you one thing. I'm super excited of being here this couple of days and spending some time with you. I never imagined 9 years ago when I left that I would see an incredible and powerful community as I'm seeing today. And I have to tell you, we did this in the morning, but I do have to do it again. All the guys from DSPT, can you guys just stand up, please, and put your hands up? And everyone else, can we give a big round of applause to these guys? You guys are really doing a phenomenal job, and for me, it's a great honor being here, just having the opportunity to talk to you about what I do for a living. And this is also a great opportunity for me. It's the first time I'm in Portugal talking about what I do. And in any other place in the world, when I'm talking about what I do, I have always a struggle. When I say I'm from Madeira, nobody understands. So I stop and I say, I'm from the place where we have the best footballer in the world, Ronaldo. They still don't understand, but they bang their heads thinking that that's cool. Talking about Ronaldo and being here, being part of an airline and airports. The president of Madeira have changed the airport name recently for Cristiano Ronaldo Airport. So if you guys lived in London like I did for a while, sometimes it's very funny. We are inside the airplane, landing in Madeira, and there's some woman or man, depending on their taste, saying, we're landing into Ronaldo. That's cool. I won't judge. Guys, I'm here to tell you 3 things today, if that's okay. Number 1 is, when you're scaling data science on traditional enterprises, it's very difficult, I'll tell you. And I've done it in many different places all around the world. So the 3 key message for you is, you have to focus on foundation. And we're going to see what that means in a second. So that's the first message. You really need to focus in foundation. The second thing is, you have to be obsessed by production. Every other thing you do, it's a kid's game in the playground. You have to be focused in production and reaching that as fast as you can, and then evolve from that, irrespective of algorithm choices and etc. And the third thing, if you really want to drive value across an enterprise, irrespective of 10, 20, 100 use cases, you have to take them by the hand. You have to handhold them and really bring them to drive change on their processes, change in the way they do things. By the way, they probably have been doing that for 20 years. And in order to kind of go through those 3 things, I have prepared a little bit of a journey for us to go through. Is that okay? Is everyone okay with that? Yeah. Okay, cool. So a little bit of context. I don't want to talk too much about what I've done, but I think it provides you a little bit of context of what I've done to date. And then we're going to look into what I believe. Look, I'm a trained consultant, so there's only 3 things we can always talk about. So we're going to look at the 3 maturity level model for data science, right? After that, we're going to go through the foundations. We're going to see, I'm very big into automation, DevOps, platforming, so we're going to see some stuff around that. And then we're going to look into a real use case at the end, which hopefully will resonate well with you guys. So let's go through it. So look, I've started my career in Portugal. I've done some research in university, went into Deloitte, then went into EDP. That was actually pretty cool at EDP because I did build a real-time platform that went into production in a short period of time where we're streaming sensor data to do some crazy stuff, like you left the fridge open on a supermarket. And we did that for water, gas, and electricity. I then moved into Deloitte, UK, and that also US, stayed about a year in San Diego working with big turbines and kind of really thinking about maintenance in the context of big assets. I've worked a ton amount of time with gas, water. My key point is not about what I've done, it's about I have been all over the world solving problems, very complex problems, small, big assets, turbines, gas networks, water networks, pumps, you name it, customer churn, fraud. And at Think Big, I, in addition to having solved these problems, had the ability to build teams all over the world, from China to Japan to Australia, Singapore, Europe, America, Mexico, etc., Colombia. And that gave me a little bit of a DNA around being very close to what data science and data engineers need to grow, to really go from university to becoming an executive, to being able to go and sit and review code to, in the same time, being able to sit next to a CEO and tell him, we need $2 million investment to go and do some crazy stuff. And that, guys, it's quite important. And of course, when the Think Big Days finished, that was startup, I then joined Emirates to build the data science capability from scratch on a centralized team, which we're going to see some of the things that I've done there in the last year. So what actually this teach me was that we do have basically what I believe a free A model for maturity levels across the enterprise. And you guys are probably going to have some fun going through this with me. So the first one is what I call aspirational data science teams. What does that mean? Well, how many of us have seen business after business saying, I'm going to hire a PhD, the guy's going to come in and we're going to smash it, right? He's going to solve all my problems. By the way, I'm going to put him in that team. Maybe I'm going to hire another one and put him in that team. Guess what? 1.9 years, 2.1 years, the guys left. And they left with all the knowledge, and you'll have to go back to the beginning. Maybe you're going to do a POC, and maybe you're going to get some of those crazy vendors coming in and saying, oh, we have AI. It's very powerful, and it does crazy stuff. And it's a linear regression, and it's so good. And it's really important. You really need to do it. And you do that in 8 weeks, and then you say, well, what was the value? It was that reach production? Never. And they go in circles. And by the way, I'll just tell you this. 85% of the companies in the world are here. They don't admit it, but they are here. Then there is a little bit of what I call an ambitious data science team, right? They're a little bit more serious. They're not that serious yet, but they're a little bit more serious. They focus on foundation. They focus on production. They focus on processes. They focus on people and how to grow it. And that, I have to admit to you, it's really the beginning. And then when you bring to the next level, which probably there is around 2-3% of companies around the world that reach this state, you have the autonomous data science team, where actually the agenda of data science is driven by their own executives. Tesla CEO is driving AI in Tesla, for example. Same with Google, potential Facebook, etc. They are really driving the agenda. Don't worry, I'll send you the slides after. You don't need to take pictures. It's okay. We can give you all this, don't worry. And I'll tell you one thing. Only when you reach an autonomous state, the ratio between revenue and investment in data science, actually the other way around, will start to have less zeros, maybe less 10 zeros before that one shows up, right? And that's really difficult to achieve. And I'll tell you one more thing which confuses the hell out of people. There's a massive difference between applied data science and research data science. And when you're at the bottom, right, you don't have the capability to bring a PhD to do research. You have to apply it. You have to drive value. You really need to show results. And when you go to an ambitious level, yes, you can dedicate slightly a little bit more time, but it's still very early on. Only those 2 or 3% of companies around the planet have enough capabilities and investment to really focus on the research side of it. No, don't confuse not doing research with just choosing models out. No, you have to kind of fine-tune models and algorithms. I'm saying being a consumer of TensorFlow versus being the one that creates TensorFlow, it's a completely different thing. And we make a ton amount of mistakes looking at this. So that's my first really advice. What type of data science are you? I'll tell you. I'm building one, and we are ambitious at Emirates. We're not autonomous. And it's going to take me 5 years to take them on a journey to become less aspirational and a little bit more ambitious. And I admit it. And I work hard every single day in each one of your careers to make sure that you have a path to grow, that we have incredible use cases to work on, that we do the most interesting work around the planet, but on the applied side. So that's a very important message. So a key kind of characteristics of traditional enterprises. They are slow. Oh man, they're so slow. A decision takes forever. And ever, and ever, and it never stops. They're so slow. And I'll tell you, for you to navigate through it, it's so complicated, right? You want to talk to the VP of marketing, you want to go and talk to the, oh, that's so complicated, and you know, oh, you first have to go and talk to my PA, and it's so difficult, right? And that's the world we live in. And I have to tell you one thing. if the revenue keeps increasing and the profitability is kind of okay, they're never going to change. I mean, me changing, come on, I mean, we're okay. Well, you just do that POC thing, so we show the CEO we're doing something on that AI, or maybe do something on the RPA and change something, fine, we're good. And that's a big challenge, because a lot of the things you have to understand is us surviving a company if we are change agents, if we are disruptors, if we are really on the adoption and change so that you can take advantage of automated systems with them out to really take on a particular process and make it better. So really, these are the challenges that I have faced across the enterprise. And I'm not saying this is best practice, this is the practices that I've seen all over the world. And hence my big emphasis on foundation, right? So the first one message that I wanted to take is build the foundation. And what exactly do I mean by that? I mean, focus on building an incredible capability around people, processes, technology and automation on one side. And then on this side, focus on how you're going to deliver at scale, fast, agile, with a massive production-oriented mindset. Okay? So because of my talk, even if I said that if I did a joke, they would give me 5 minutes, I don't have time to go through all of this. I have selected a few of these items for us to go through. Is that okay? Is everyone having fun so far? Okay, cool. So, people side, I'm very obsessed about this. First one is organize your team to scale. So my teams, they are always organized this way. There is team lead, kind of director level, senior data science, and map to equivalent on engineering side. So a data science, ideally, if I'm starting small, I don't have the luxury to bring someone out of the university straight away. So they will have like a few years of experience, and a team lead could have up to 10 years of experience. So again, and there is a reason why I do that. But putting them in titles and levels means nothing. If you do not have a career path, if you don't have a training curriculum, that all goes into the corner because they don't have a path to grow. And for you to have a path to grow, you first have to invent a recruitment methodology that maps to those levels. So currently, I have a particular path for each of those levels, where the second path is a live coding that we do in the language that you choose, right? But aligned for each level. And of course, the complexity of the exercise is lower or higher depending on who I'm hiring. And that's important, but that's nothing if I don't map an incredible and powerful learning path and training path to get everyone into a level, which is my role. My role is to turn data science into executive data scientists in the future. People that can articulate a problem and talk to an executive from one day to the other. That takes time, right? And it's not about just teaching you the technicalities of it and being always ahead of the game with what's coming. It's the communication, the sales, the conversion, and everything that we sometimes don't like because we think we know everything, but it's very important. So for me, this particular area that I wanted to focus today is very critical for the foundation to work. Bad people in, bad output out. We joke about data, bad data, right? It's the same. Bad people in, bad output out. So you have to really think carefully about this. The second thing is the processes. And I'm just going to put here, the first thing is, capturing data. We talked, there's incredible talks today about feature engineering, automatic engineering. Yeah, we're going to need to transform the data. And a lot of times it's not even feature engineering, it's putting the data together. And then you're going to do reporting, et cetera. And then you have to kind of integrate it into operations. As a process, it sounds quite simple. And you will understand this in a little bit more detail. I tend to not look at this left to right. I do the opposite. For every use case, I go from right to left. So what is the product I'm going to invent? What is the users? How are they going to use it, interact? Then let's go back into how I'm going to need to integrate this. Then what models? What data? what success looks like, what's the SOA, is it real time, is it not real time? And that enables us to have a completely production mindset and being obsessed by value and change in production and not bothered about, do I have the most incredible algorithm that beats 99.999.999, okay, but reach production in 6 weeks and evolve and drive value out of the gate. And that is so critical on enterprises, that you're taking them into a journey. If you take a lot of time because you thought, oh, I'm going to try all this stuff, and it never reaches production, you're wasting everyone's time. And because of that, I have invented this methodology. I'm not saying it's good, bad, I'll let you guys decide that. I use it. I have used this time and time again. It's a very simple methodology. It's a three-stage approach. Demand comes in, demand gets assessed. There's 4 things I do in assessment. One is I check the data, the problem, the process towards production, and after all of that, I analyze the success criteria for that particular project. What does good look like? And then I put a mathematical model, of course, that weights each one of these parameters and then gives me a priority, which ones should I be focused on. And then I take the use case based on the capacity of the team to an exploration phase, which I tend to do it in like 8 to 12 weeks. And in those 8 to 12 weeks, very roughly, we always will solve the problem. We'll take it, whatever it is. I'm not saying that we cannot be better, cannot evolve, we will take it to production. And we work, we essentially assign a team lead, a senior data science and a data science to each problem, and they work on that time frame. Of course, a project could take 14 weeks. I'm not saying it's not, but averagely speaking, that's kind of how it takes. And then we take the project into deployment, where we mix a little bit the team, bring a little bit more engineering and separate. But the key point is deployment for me, as you will see later, it's not about wasting time with putting models into production. It's about integration and driving change, because that part that I just said is fully automatic. And if you're not doing it, I mean, you're wasting your time. And I will tell you a little bit about that in a second. So a very simple model. And you need to have this model to capture demand, create demand, and actually take it across the enterprise. Otherwise, it doesn't work. People don't know what you're doing. People don't know how many things you're doing. And that's very critical. So far, so good? Okay, we're going to go deep into some tech stuff. For you, it could be exciting or boring. I'll leave that to you. For me, it's exciting, but let's see. So let's talk a little bit about tech. So, I mean, I have a very simple methodology and a platform. It's completely agnostic. You can change the colors and it would work. It's basically, I have an exploration environment, and I have 2 deployment environments. One is called automation, the other one is scoring and serving. And I connect, of course, data into it, all types of data. I mean, you will see this in a little bit more detail. Now, I do this because I built all the automation with DevOps to get this always up and running. And I built this methodology, and again, it's not very different from what you have out there, but helps us to scale. And this methodology is based in Docker. Actually, I do rely a lot on it. And everything you're going to see next is in Azure, but to be honest, I've done it on AWS, on Google. It doesn't matter, right? Just take it as granted. So it's a concept around like a bridge, and a bridge to separate compute and storage, and to be completely agnostic about libraries, methodologies. And of course, when you have Docker, you have to store that somewhere. So I'll take the example of ACR. And then everything else is really this logic between a VM and Kubernetes, right? So of course, on the VM, you're going to have your IDEs of choice, your orchestrator of choice, your scheduler of choice, mixed with containers. So I run vanilla Spark on Kubernetes. I run vanilla TensorFlow on Kubernetes. Everything runs in Kubernetes based on these images, because I will take a Delta approach to deploy stuff automatically. So, oops, this went the other way around. So the platform that I have is very simple. So the exploration and automation is 2 very similar environments. The automation just takes the projects to be scheduled on a regular basis, but they work exactly the same way. And I have all the kits in the ground. I mean, the latest and the greatest and etc. They all run in Kubernetes. One thing that I do, though, which is potentially different, is I bring optimization as well into this picture with things like FICO and Cplex, even if they are not open source. There's a lot of optimization use cases out there. And if you don't have kind of multi-armored bandits or equivalents, you do have to kind of go to more classic optimizers, and there's a lot of applications that take advantage of that too. Now, so that's the exploration and the automation side. Nothing runs on VMs. everything that you do essentially triggers a container to start and to run. So if it's Spark, it will be a few containers. If it's TensorFlow, it will be one container potentially. And then one last thing, I have this for CPU and GPU completely out of the gate. And I'll tell you how I automate this in a second. On the right side, it's pre-custom built images for serving. With all the kits that you want. So basically, if you create vanilla images that have that capability, as soon as you start deploying, you just attach the project into it and then serve it. And everything runs in containers at scale. And then you can configure Kubernetes to kind of do everything you want. Right, so third level of detail, same platform, just with some use cases there, data. The other thing that is very important is for you to plug this into the systems that this needs to run into. So when you deploy solutions into containers, they still need to be executed. So if it's, for example, in the context of marketing, you're going to have a marketing execution engine running real-time campaigning to your users, right? You want to have the container fully integrated into that particular execution engine. I'll give you the example of Box Server, but on Salesforce, you could also do it in batch, where you actually store the data into enterprise data platforms, and they run, again, at scale. My key point here is build this thing to run very fast. Conscious of time, I can take everyone through more details on this later on. I just want to highlight that side by side, the capability to have the platform, you need to think about automation. So basically, what I have done here, and I have the details, but I'm very likely not going to have time to go through it, is to just say, everything I have done that I showed you in those slides, it's fully built with DevOps. It's fully automated in the cloud. What it means is, when I want to put a new library in Python or etc., we just have to go link the Jira story into a Git commit. I'll spin up a new environment, and then when you're done, you're going to do a pull request into Git. Test environment gets spun up on the cloud, does automatic testing, brings it back to master, and then you have the repository for master on the platform that you can schedule to have daily builds, weekly builds, and everything goes with it. So if you do this very well, you will end up on this situation, which is you have your production platform, which at a particular trigger, basically a scheduler or a commit that you do, you can have new platforms being available to the data science and data engineers, and they don't even notice there is a new thing coming, because everything is fully automated for them. And that's when you drive scale across an enterprise. So, second message, obsession production. I hope I covered that by showing you the platform and the automation that comes with it, right? And that's very important. Third thing would be done by a real use case, okay? I hope you're having fun so far. I went a little bit deep, but I was asked that we need to do that. So I'm going to take it up now. IATA is the body that controls airlines. And this is very boring what I'm about to say, and I do apologize for that up front. We waste 5.7 million tons of food on the cabin classes of all the airlines combined in the planet. Guys, there's people dying without food. IATA says 5.7 million tons a year. Can you imagine how much food that would be? It's probably like hundreds of equivalent sizes of this room. That goes to the bin every year. So when I took that use case, oh man, I said, I'm going to go and just smash this, because there's a massive sustainability play behind it. And we, in business class, we basically offer you choice. For those of you that had the pleasure to fly with Emirates in business class, we have choice. We give you chicken, seafood, red meat. And for me to give you choice, I have to uplift into the aircraft more food than passengers, so that you always have the choice you want. And in the past, the caterers, by the way, 200 all over the world, they essentially take the numbers Emirates provide and make some calculations to calculate how much food to uplift. So that was the challenge. I forgot to tell you something very important. Emirates is probably one of the only carriers around the world that have a device on board to track what you order. So basically, taking that data, what was uplifted, the passengers and the flights, I've built a framework And look, guys, I'm not going to talk about models because we don't have time, but trust me, I've tried dozens. And every day, this is running in production, every day there's dozens of models kind of competing. I have a champion challenger methodology that just says, is it TensorFlow that going to win, or is it gradient boosted trees, or whatever, right? And whatever wins in that particular day will be deployed to production, and then this runs at scale. We have 500 flights a day, 200 caterers taking care of this, so you guys can imagine. But the key thing here is, when you combine all this data together, that was never combined before, you build for every flight, for every meal, for every item, for every recipe, like the red meat recipe, you have 700 features to actually predict what would be the consumption for that particular flight. So you have data that is related to the flight, data that is related to the time, the cuisine. You know, maybe Italian goes well with Spanish people, but the other way around doesn't work well. So you have to really combine all that intelligence and really put this into the hands of the people. So, I mean, look, I have all the details of this. I can talk to you a little bit more about this. This is the solution that runs in production. I have real-time capabilities. This runs at scale in production against all the flights that we have. And the key thing is really, what have we achieved? And with that, ladies and gentlemen, I hope you had fun going through this talk. It has been a great privilege to be here with you today. And if you have more questions, I'm happy to take it offline. Thank you very much.